Hi there. How's it going? I hope you're having a wonderful day and welcome to another session of Brain Training, the place where I train my English by explaining LeetCode solutions. For today's session, we're going to tackle the longest common prefix. So, the longest common prefix, first thing we should do, like always, is to understand the problem requirement. Putting this in simple terms, the problem wants find the same initial part across all strings in this array and return it. And the name of this initial part is prefix. What is a prefix? Just the initial part of a string that could be as small as the empty string, as a empty string, or as long as the whole string or the entire string. Now that we know what the problem wants, I will bring up some examples so we can understand how we're going to solve this problem. By the way, this is how I came up with the solution on my own without knowing that the solution had a name. It's a vertical scanning. It's the official name of this technique. But it's nothing fancy, nothing obscure. It's just pure logic. This is why I like it. So the whole idea of this approach is to take the first string we have within the array, take the first character, and compare this character against all remaining strings, checking if whether or not they are the same. If so, we're going to increase the portion we are taking from the first string and comparing against all remaining strings in the array. And we're going to do this until we reach the end of some string or until we find a mismatch. To better visualize how this approach works, I'm representing the strings as char arrays so we can better see how we are iterating over each string. Because of this representation, we can see why this technique is called vertical scanning, because we are doing like this. We are just looking in the vertical. We are checking vertically. Vertically, we are checking these strings vertically. So our code do something like this. Let me just make this easier to understand. What we're going to do is we're going to grab the first character of this string and compare it with all the remaining strings, like all the remaining strings in the array. That's what we're going to do. If the initial part of all remaining strings is the same, we're going to save this part in our prefix and increase the size of the portion we take from the first string. And then compare this portion with the remaining strings here and here. They still the same, so we're going to save this in our prefix, our current prefix. And we're going to increase this again. So now the first string over here, we're going to increase to flow, and then we're going to compare with the remaining strings. It's the same, but here we find a mismatch. So we're just going to return the prefix we got so far. That's how our code works. Another example. Let's go. So again, we're going to use the first string, take the first character, and then compare it with the remaining strings, just like this. So we are good to go. After that, I move to the next position. I forgot to mention this. I have to move to the next position and then grab the entire portion. This is why we have this index plus 1, because we are taking this portion over here and comparing again against all strings. We are still good to go. So now we update our prefix and then we increase the range that we're going to take from the string and compare it. Okay, comparison, everything's good. Everything's good. We reach the end of the all strings, so we can update the prefix. Increase again the initial part of the string. It's this part over here. And we're going to compare against all strings. 1, 2. Actually, this is the string we are using as the initial value. So we're going to just compare with this one, and here we are good. We're good to go. just update this. Better visualize because this sub is just like this. Sub and that point over here, or sub string, could be the prefix, but this is just a temporary variable to hold the portion we are comparing against. Has this value over here. Now we are comparing with the second string, and then we try to compare with the third string, but we reach the end of this string over here. So this is another condition to return. So the prefix will be this one over here. So this is the longest initial value. There is the same across all strings in this input array. Now I'm going to show you how I wrote this code, and then I will explain after. The code goes something like this. This is what I came up with. Just checking if I didn't messed up anything. Yeah, of course, the typo right there, substring typo. Nice. So let me explain what this code is doing. So starting for the variables we need the I position just to increase the size. We're going to use this to increase the size of the initial part of the string. And we're going to use this variable here to keep track of the prefix or the longest initial part of the string, if you will. So the first condition to break out of this loop is if we already reached the end of the first string. If so, we're just going to break out of this loop, returning the prefix we got so far. After that, we're going to take a portion of the string to make the comparisons against the remaining strings. But here I'm just using the substring function. The substring function in Kotlin requires the initial position. So in this case, always going to be at 0. Is start from the beginning of the string, and also requires from that position how many characters do we want. Then we're going to iterate over all remaining strings. Not actually all remaining. In my code, I'm doing some redundancy because I'm iterating over the first string again. I'm taking the portion from the first string, and then I'm doing the comparisons against the first string again because I'm iterating over the entire array. Instead of starting from the position 1, I'm starting from the position 0 here. It's kind of stupid. It's not a smart way to do it. But in order to change this, I have to check against the... I have to check if the input array has a single string. If so, I have to return it right away because I don't need to go over the entire loops because I know the prefix will be the whole string. Yeah, I'm doing some redundant stuff. But with that aside, here we're just comparing whether or not we reach the end of this string or if we will find a mismatch. If we reach the end of this loop without returning, we're going to update our prefix with the current substring and increase our pointer so we can increase the size of our substring in the next iteration. In the worst case scenario, we're going to do this until we reach the end of the first string. I'm going to break this loop just by returning the prefix. The compiler never going to reach this part because if we reach the end of the string, we just return from here. If we find a mismatch, we're going to return from here. The compiler never going to reach this point over here. But we do anyway because this function requires a return statement. Regarding the time complexities, kind of is interesting because for this outer loop we have a time complexity OS. This is interesting, right? This is the time complexity for this loop over here, the outer loop. In the inner loop we have the common O of n. So n is the size of the input array. With that information, we know that the overall time complexity, I think overall is spelled like this, I'm not sure, overall s times n. So we're going to iterate over all the strings s times. So s times n is our overall time complexity for this algorithm. This is really interesting. I find really interesting. Okay. And for space complexity, we need an extra space equal to the size of the first string. for my implementation. Other implementations that I saw, they don't even use those variables. It's so infamous extra space that we can consider this constant time. Just to wrap this up, I'm going to use my laptop camera. It's worse quality, but get the job done. So yeah, I think we are finished here. This is the entire algorithm. This is the approach that I use to solve this problem. A nice problem. I like it. Nice performance. Pretty straightforward. I hope I have been clear and precise in my explanations. And I'll see you in the next video. Bye.